because let's face it, that's going to be the most challenging out of all word problems, right? So we'll go ahead and start taking notes on that. Okay, so with word problems, you will need to read carefully, right? Read very carefully. Draw triangle and label. Determine the don't know, don't care side, right? Pick the right trig ratio, right? Pick SOHGAHTOA. Which one is it going to be out of the three, right? And obviously solve and answer with statement. Units as well, right? Don't forget the units. Is this did I just give you the steps? No, I basically told you, right, what to take into consideration when dealing with a word problem. Because if there is no diagram provided, it all really hinges on you reading carefully and kind of and don't be scared to start over, right? Sometimes I find students want to make their diagrams and then they're kind of stuck with it. Say, hey, it's not working, moving on, right? No, like you want to try to see, okay, this isn't working, this doesn't make sense. Do I need to, draw it upside down? Which sides are they giving me? Which side would make sense? Um, which one are they asking for? Sometimes if you know which one they're asking for, then the one that they're giving you is easier to put on a certain side, right? Because there's going to be three sides, and only one is going to be given, and the other one will be asked for. Okay, so you need to be able to kind of discern and interpret the questions there. And there are two different angles that are very important to us, and you will hear them over and over again, and they're called angle of elevation and depression, right? So I'll just box this in kind of so you know. And so angles of elevation and depression. Okay, so we have so here I would like to just give you a bit of a visual first. So imagine, right, there's a person here like that, and imagine there's the right the line there's the horizontal coming straight out of like eye level in this case. If you consider the horizontal, and now I'm lining up the horizontal line with where the eyes are of the person, but it doesn't need to be. We'll just call this the horizontal. The horizontal could be the ground, right? It could be the ground. It could be, when we're talking about a lake, it could be the surface of that lake, right? Surface of the water. Anything that's horizontal that goes sideways is obviously our horizontal line. And it is from the horizontal that these two angles that we've just talked about come about, right? So I'm going to use two different colors, right? The angle is always formed between two sides. Remember that. So if you go from the horizontal and you go upwards, the line of sight going up. So let's say you're looking at a bird up here in this case, right? Then that angle formed here is what we call angle of elevation. Okay. So between the horizontal and a line of sight going up is the angle of elevation. Examples of using angles of elevation is a plane taking off, right? A plane could be taking off at an angle of elevation of 20 degrees. It could be that a plane is already flying at a certain altitude and then it changes its altitude by using an angle of elevation of 15 degrees, right? But it's the idea that you're going between the horizontal and the line going up. Okay, so angle of elevation is there. When a person, right, is standing next to a tree looking up to a squirrel, right, like angle of elevation, you're thinking between the horizontal and the line of sight going up. There it is. And then you have your angle of depression, right? So there, let's pretend there's a bug down here, right, crawling, right? And so the line of sight to that object between the horizontal and the line of sight going down, that would be the angle of depression. Okay. And so you need to know that. Okay. So let's talk about angle of elevation, right? It could be the classic setup is like this. This would be your angle of elevation. Okay. It could also be going the other way like this. This would still be the angle of elevation. Okay, it's between the horizontal and the line going up. So that angle is referred to as angle of elevation. So sometimes just by hearing it or just by reading it, you will know, okay, I know which way between which two sides this angle is created and what the triangle is going to look like. Okay, depression is like this. Okay, your resulting triangle will look like this, and so the angle of depression is there. Okay, could also be the other way. Depression there. And here's one that a lot of students get this one wrong. If I were to give, sometimes there's a triangle that looks like this. And students will say that this is the depression, angle of depression, and this is wrong. Okay, wrong. The angle of depression here is not, like there's no horizontal line there. Do you notice that? Like the horizontal line, let me get the wrong out of the way here. This is wrong. Okay, the horizontal line is up here. So technically this is the depression. This is the angle of depression, not that one. So a lot of students get that one wrong because it throws everything else off. Okay, so keep that in mind. So I guess for the depression, I give you one where it's wrong. If you were to say that the angle of depression is there, it's not correct. It would be here if you were to extend your triangle in that way. Okay. So I could ask you label the angle of depression or elevation in this triangle. Then you need to know where you would find them. Okay. There's no horizontal in this one. Up here, at least, there is no horizontal, so that would not be the depression. Okay. Okay. Let's keep going here. Example 1. I'm just gonna call this example, right? The angle of depression. There's that, right? Those 3 words there. From the top of a 80-meter cliff to a sailboat is 21 degrees. So just write this down, okay? Determine the distance from the base of the boat, sorry, the base of the cliff to the sailboat. So once you have written this down, let's go kind of through the steps. The angle of depression, right? It's important to me. I'm going to underline that. It's a key word, right? Keywords from the top of an 80-meter cliff. So we know that it's the vertical. It's definitely a vertical. Height is always measured vertically, right? Up and down, right? So the angle of depression from the top of an 80-meter cliff to a sailboat is 21 degrees. So there's some information given in between, but we know that the 21 degrees refers to the angle of depression, right? Because it's an angle. And then we're asked to determine the distance from the base of the cliff to the sailboat. Okay, so let's imagine the situation here. It doesn't matter where you want to draw your cliff, but if a cliff goes steep down like this, right? And there's water here, and there's your boat somewhere back here. I'm not an artist, so don't worry. I just know it has a sail, right? Like that. So we know that from the top of this cliff to, it doesn't matter, don't overthink it, right? But to that boat, the angle of depression is 21 degrees. How would you draw your angle of depression? Well, since there is no horizontal, right? We need to kind of extend this cliff as if it's continuing horizontally, right? So just imagine that there's this line. It's almost like an imaginary line. But between that horizontal, right, and the line of sight looking down, right? Between that, there's what we call the angle of depression, and that is 21 degrees. So that's where you place the 21 degrees. And slowly our triangle is coming together here. We know that the cliff, right, the height of the cliff here is 80 meters. Sorry, 80 meters, right, that. So from the top to the surface of the water there, it's 80 meters. And so oftentimes you'll see 2 triangles up here. There's one here, but there's also one here. right? This is our 90-degree angle. We know the angle of depression. The 80 meters here transfer over to here as well, right? Because 80 meters on this side or on that side is going to be the same. So we have 80 meters here also. So quite often you'll see a rectangle and a diagonal that cuts that rectangle. And you will notice that both of these triangles are actually the same. One is just flipped upside down. Okay. So we know that we have this information. So we've labeled, we've labeled, and there's one side that you don't know and don't care about. So let's figure out which one they care about. Because we labeled, we know this is 80, we know that's 21. So one of these two sides we're not going to care about. So let's keep reading. Determine the distance from the base of the cliff to the sailboat. So there's a distance that is straight down, like this would be the direct distance, but they want the distance from the base of the cliff. Base of cliff, right? Would be right there. That's the base of the cliff here. So they want the distance from the base to the sailboat. So that's what we call X. X, Y, Z, we're going to use a lot of those letters. Okay. So it's this side here that they care about, which is also the same up here, right? This side here is also our X. Like it's remember it's a rectangle, so you can do this or you can do that up there. So I'm going to use that triangle up there to solve this. Okay, I'm going to use this one up here. I will make a note here. Note: you will often see a rectangle with identical triangles. Okay, you can pick whichever one you feel most comfortable with. So, Mr. Dirksen, are you saying these two are identical? Yep, they are. If you were to take this one, the top one, and just rotate it, it would actually be this one here. So if you follow, this 21 is actually going to end up here. And you're going to say, Mr. Dirksen, isn't this the angle of elevation? You are correct. The angle of elevation and depression happen to be the same. Always. Okay. What is incorrect is to say that the 21 goes in here. That would be incorrect. Okay, that would not be correct. So 21, we had to put it here, which I'm going to stick with angle of depression right now because it's very important that you know that it goes here. So I will use that one. So I'm going to call this triangle 1. And oftentimes you will see me taking it out and relabeling. This is 21 here. This is 80 meters here. And so this one is the one I want. So I'm going to label, okay? Going from this triangle because that's my reference angle. This is the opposite side. This is the hypotenuse here. Sorry, you can't see there. Based on the 21, this is the opposite side. This hypotenuse, I don't know and I don't care about it. So this must be the adjacent, right? So it's O and A. So I have to use TOA to solve this one in particular. So tan of, remember it's always an angle. It's either a letter or in this case an actual numeric value, is equal to opposite, which is 80 meters. Very important to not, that's a common mistake, not putting them in the right place, folks. Okay. So it's opposite, which is 80, over adjacent, which is X. And there you have your setup. So I redrew it. I determined which one to use. I set it up. And now it's solving, right? So multiply both sides by X. That cancels out this. So you get X times tan of 21 degrees is equal to 80. We're going to divide both sides by tan of 21. Don't be scared of that. That's just a number. And so x is equal to 80 divided by tan of 21. And that's 208.41 meters. 208.41 meters. I don't have the hypotenuse here, so I can't really say. A quick check I always do is make sure that my legs are shorter than the hypotenuse. Okay, so I'm just gonna leave it at that. So I will say the horizontal distance from base of cliff to boat is 208.41 meters. Just a little sentence, doesn't have to be a paragraph, where you tell me what your final conclusion is here. All right. Backside, more examples. Line it up. A 30-meter line is used to hold a helium weather balloon due to a breeze the line makes a 75-degree angle with the ground. Determine the height of the balloon from the ground. So write that down. So in this case, how about if you take some scrap paper, okay? Sometimes it's better just to without. So just imagine the situation. You've got the ground here, and you've got the weather balloon, right? So it could be on this side here, attached to the ground, or it could be floating somewhere over here, right? If this is our balloon here, it's attached to the ground. Either way, whichever way you want to go, right? You have the ground, you have the actual height, and there's your 90-degree triangle formed, right? Or your right triangle. Over here, you have your right triangle there. I'm going to make a good diagram just now. I'm just letting you know, right? Various ways to graph it. Um, and just so you know, but always remember there's a rectangle in this situation. So if you were to look at it this way, there's a diagonal, right? And this side is equal to this side. The horizontal here is equal to that one there. So often you can transfer information over sideways, right? Up and down or sideways, but the diagonal, which is our hypotenuse, stays the same. Okay? So regardless of which one you graph, always remember that that rectangle is there. And often you don't even need to graph the rectangle. You just come up with a triangle right off the bat. That's fine. But just remember it's situational. What is happening here? Interpret, right? So we have our ground, and the helium is attached to the ground. And because of a breeze, instead of going straight up, it actually goes off to an angle, right? So this is our balloon here, okay, flying sideways there. And it's saying that there's a 30-meter line holding it, right? So this line here is going to be 30 meters, okay? Due to the breeze, the line makes a 75-degree angle with the ground. So that 70-degree angle, obviously it's the shorter one. Don't go this way, right? Because you know this one is bigger than 90 here. You want the acute angle, which is 75 degrees, which is right there. Okay? And then there's the height here. This would be the height. Height is always measured vertically, right? Straight up, right? Everybody. And so you know that there's a 90-degree angle formed between the height and the balloon. Sorry, the height and the ground here. And so they give you an angle and a side, okay? And then we need to now say determine the height. So this is going to be our x here. Determine the height of this balloon from the ground. By the way, this angle right here, they're not always going to use angle of elevation, not always going to be using angle of depression, but we know that that angle there is angle of elevation. So this is an example of an angle of elevation scenario, right? So just to keep that in mind. All right. So we care about, we know this one, obviously you're going to put that down. We care about this one. They want to know what this is. So this is our don't know, don't care, right? Don't know, don't care side. So we kind of ignore this one. So from this reference angle, we label opposite, right? And this is the hypotenuse. We're going to label that like that. So O and H, H and O, it doesn't matter. You know it's so, right? That's the only one that works. So sine of 75 degrees is equal to opposite side, which is, remember, opposite first, which is x, then the hypotenuse is 30 meters, sorry. And remember, sine, cosine, tan are always glued with an angle, right? So then this one is the easy case, right? You multiply both sides by 30. This cancels out. So x is really just 30 times sine of 75. 30 times sine of 75 is 28.98. And that is in meters, right? Because we're finding a side length here. Okay. The height of the balloon is 28.95 meters. And it's one of the legs and it's shorter than the hypotenuse, so we're doing good. Okay. If you, I'm just give you an example here. If you had mixed up these here and put the 30 on top and the x at the bottom, this is what you would have gotten there. 31.06, which cannot be because the hypotenuse is the longest side. And so you're now saying this is longer than the hypotenuse. You can't have that, right? So keep that in mind. One more example, and then you'll be on your own. Just listen carefully. You don't need to write this down. How could it have been worded differently where they asked you to find this side here? Because the wording is going to throw you off. And so one way I can think of that they would word it in such a way that they're actually referring to this side, it would be determine the horizontal distance from the anchor point, right, to the balloon. So if it's horizontal distance, they're asking from the anchor point, it's anchored here, right? And they want the horizontal distance. So you got to go from anchored horizontal to where the balloon would line up, right? So they're asking for the horizontal distance here. So you got to be careful. Which one are they asking me for? How do I know? If it's a ladder, right? And you're leaning the ladder against the wall, what's the horizontal distance between the foot of the ladder and the base of the wall, right? Like the foot and base, they're referring to, right? It's along the bottom, not anything else there, okay? So watch out for those keywords there. And you'll only learn math by doing math, right? So you'll try this. Okay, so another one. Mr. D is sitting on a dock watching an eagle in the sky. At a certain point, comma, the eagle is 300 meters above the water. And 430 meters hold on. The water and 430 meters away from Mr. D. Determine the angle of elevation so write this down. Okay, so imagine this is the dock here, right? And I'm sitting right here, and the eagle is right here. And sorry, the dock is supposed to be pretty much flush with this, the dock And then there's the water here, right? And the eagle is up here. And there's a point where the height, right? The eagle is 300 meters above water. So this is given to you here. The distance between the water and the eagle vertically. And we're also told that the distance at that same time, the eagle is 430 meters away from Mr. Dirksen. Okay? So this would be 430 meters. They don't say the horizontal distance or anything, so you're assuming that it's this one. And you're also looking and you're like, it makes sense because the hypotenuse is longer than the one of the legs, so I'm good. Okay? So and then you automatically just make this the water, you close it in, and this is your triangle that you're formed here. Make your 90-degree here, and then you have your two acute angles there. And we can now call this angle D and that angle E if you want, right? And so where's your angle of elevation in this particular scenario? Well, it's definitely here, right? This right here is the angle of elevation, right? That's what they're asking you for. So which one is the don't know, don't care side? It's this one here, okay? So across from this, you have your opposite, hypotenuse. It's O and H, so you got to use so, right? So the first step is always the same. Label, figure out which one of the three, and in this case, we're finding the angle. So sine of D for doc, right, is equal to opposite, so it's very important to put the 300 first, hypotenuse 430. I will tell you what happens when you make a mistake there. You will get your calculator is going to give you an error if you don't put them in the right order. So angle D, right? Angle D is going to be sine inverse of 300 over 430. So angle D is, I'm going to go sine inverse of 300 divided by 430, and that is 44.24. Whenever you use the inverse, you're thinking of degrees, okay? So it's almost 45 degree, an almost 45 degree angle there. Okay, and let's conclude with a statement. The angle of elevation is 44.24 degrees. And there you have it. Okay. Homework. There's if you go to page 6, you get a whole bunch of word problems that that are there. And again, read carefully. Sometimes there's too much information for some of them, but you somehow have to create your right right triangle and come up with your calculations there. There are more word problems at on page 7, but I'm just going to go page 6 for today. And remember, the keys are all at the back. They're handwritten. So if I go, I'm trying to see here. Page 6, yeah, they're all right here. So if you go to the back, look for page 6 and the answers are right here. Okay, make sure you include a diagram and you're very careful with all your calculations, and we'll see each other tomorrow again, perhaps an AC